Welcome to Chapter 2 of Class 7 Science, Exploring Substances, Acidic, Basic and Neutral. In this exciting chapter, we'll unravel the mystery from the science fair where hidden words magically appeared on paper. This introduces us to the fascinating world of acid-base indicators. We'll learn how to identify acidic, basic, and neutral substances using natural indicators like litmus paper, explore color changes with rose petals and turmeric, and discover neutralization reactions that solve real-life problems from ant bites to soil treatment. Get ready for a colorful journey through the science of substances. Let's begin our exploration with Activity 2.1 using litmus paper as our first natural indicator. Litmus is extracted from lichens, amazing organisms that are partnerships between fungi and algae. We'll test various substances like lemon juice, soap solution, vinegar, and baking soda. When we add lemon juice to blue litmus paper, it turns red, indicating acidic nature. Soap solution turns red litmus paper blue, showing basic nature. Substances like sugar solution and tap water don't change either litmus paper color, indicating they're neutral. This simple color changing test helps us classify all substances into three categories: acidic, basic, or neutral. Remember, blue to red means acid, red to blue means base, and no change means neutral. Nature provides us with many colorful indicators beyond litmus. Red rose petals can be crushed and soaked to make an extract that turns red in acids and green in bases. Turmeric, our golden spice, makes yellow paper that turns red-brown in basic solutions but stays yellow in acids and neutral substances. Purple cabbage juice shows beautiful color changes from red in acids to blue-green in bases. Even flowers like hydrangea change color based on soil acidity, blue in acidic soil and pink in basic soil. These natural indicators are safe, easily available, and demonstrate the beautiful connection between chemistry and nature. You can prepare these indicators at home and test various kitchen substances. Some substances change their smell when they meet acids or bases. These are called olfactory indicators. In Activity 2.6, we use onion as an olfactory indicator. When we soak cloth strips with onion smell and then add basic substances like baking soda solution, the characteristic onion smell disappears. However, with acidic substances like tamarind water, the smell remains. Other olfactory indicators include vanilla essence and clove oil. These are particularly useful for visually impaired individuals who can identify substances using their sense of smell. This shows how science can be accessible to everyone through multiple senses. Now let's explore what happens when acids and bases meet, the fascinating process of neutralization. In Activity 2.7, we mix lemon juice with lime water. Initially, the lemon juice turns blue litmus red, confirming it's acidic. As we add lime water drop by drop, the color changes from red through purple to blue. At the perfect balance, the solution becomes neutral, neither acidic nor basic. This reaction follows the pattern: acid plus base gives salt plus water plus heat. The heat production proves it's a chemical reaction. This neutralization process has tremendous practical applications in our daily lives. Neutralization reactions solve many real-world problems. When an ant bites, it injects formic acid causing pain and irritation. Applying baking soda, which is basic, neutralizes the acid and provides relief. Farmers use lime to neutralize acidic soil, creating better conditions for plant growth. Factories treat acidic wastewater with basic substances before releasing it into rivers to protect aquatic life. Even indigestion caused by excess stomach acid is treated with antacids that contain bases. The science fair mystery we started with uses this same principle. Hidden messages written with acid-base indicators become visible when sprayed with the opposite type of substance. Let's test your understanding with some quick questions. If a solution turns red litmus blue, what is its nature? Basic, because only basic substances cause this color change. Why does turmeric stain turn red when soap is applied? Because soap is basic and turmeric turns red in basic solutions. How can visually impaired people identify acids and bases? Using olfactory indicators like onion extract that change smell in basic solutions. What happens when excess amla juice is added to a basic solution? Neutralization occurs, forming salt and water while producing heat. These concepts help us understand and solve everyday problems scientifically. Congratulations on completing Chapter 2. You've learned to identify acidic, basic, and neutral substances using natural indicators like litmus, red rose, and turmeric. You understand neutralization reactions and their real-life applications from treating ant bites to managing industrial waste. Remember the key points. Acids turn blue litmus red and taste sour. Bases turn red litmus blue and feel soapy. Neutral substances don't affect litmus paper. Neutralization follows acid plus base gives salt plus water plus heat. These concepts connect classroom learning to daily life, showing how science helps solve practical problems. Great work on becoming an acid-base expert.